Hi, we're Group 26. My name is Stephanie Maldonado. I'm currently a junior studying civil engineering with a concentration in construction engineering.
I'm Mackenzie O'Connor. I'm a junior and I'm currently majoring in civil engineering.
I'm Bill Morgan. I'm a sophomore and I'm also majoring in civil engineering.
Today we will be discussing sustainable construction. In our presentation, we will be discussing the key components of sustainable construction, why it's important, its impact on the future, and its overall worth. Sustainability can be defined as development that meets the needs of the present generation without compromising the ability of future generations to meet their needs. Sustainable practices support ecological, human, and economic health and vitality by assuming that resources are finite. They should be used conservatively and wisely with a view into future impact on their availability. Sustainability is based upon four components: economic growth, social progress, environmental protection, and responsible resource consumption. As stated by UCLA Sustainability Committee, it's all about our children and grandchildren and the world that we leave them. Sustainable construction applies sustainable practices to the construction business model in order to make industry more profitable and competitive. It also correlates sustainable practices to the four M's: materials, money, machines, and manpower. It creates circular construction, meaning that there is little to no waste, and lowers the life cycle cost analysis. Sustainable construction involves delivering buildings and structures that provide greater satisfaction by increasing well-being and value to customers and users. Minimizing construction impact on consumption of energy and natural resources, making the construction industry more profitable and more competitive. So why use sustainable construction? It helps the environment, becomes a great financial investment for the owner, and raises the standard for construction. Building and construction works have the largest single share in global resource use and pollution emissions. According to the UN Global Report, in developed countries, the built environment is responsible for around 25 to 40% of total energy use, 30% of raw material use, and 30 to 40% of global greenhouse gas and solid waste.
The use of sustainable construction is becoming more and more widespread. Sustainable construction is achieved through efficient management of materials, machines, manpower, and money. Additionally, sustainable construction techniques include lowering life cycle cost, using more renewable and reusable materials and sources of energy, minimizing waste and overconsumption of energy, and generating sustainable profit. Currently, there are three major constraints that prevent sustainable construction from seeing more widespread use. The first constraint is high upfront costs. This could include contractor equipment and on-site renewable energy sources. The second constraint is volatile trends in industry. This creates the need for a reliable supply chain. This could be more or less of a problem depending on the owner's financial position. The third constraint is accessibility to resources. If the resource is too far away, high transportation costs would make sustainable construction practices difficult to implement. The organizations listed here provide practical systems for measuring and reporting sustainability in construction projects. BREEAM and CEQUAL are both run by the same organization. BREEAM is used for evaluating buildings and master planning projects, while CEQUAL is used for other types of civil engineering projects. LEED, which stands for Leadership in Energy and Environmental Design, is run by the U.S. Green Building Council. A couple of other organizations which also evaluate sustainability are the Code for Sustainable Homes and the World Green Building Council. Sustainable construction will provide an opportunity to redefine the perspective of value engineering, from a cost-cutting measure to a process to provide additional value to the finished project and the project owner. It could also provide more leverage for contractors to seek out efficiencies with design-build lump sum contracts. In the future, contractors could improve efficiency and quality control with automation. Automation will create jobs in some sectors and cause people to lose jobs in other sectors.
Two examples of completed sustainable construction projects are the Rosa Parks Elementary School in Portland, Oregon, and the Gish Apartments in San Jose, California. Both constructions were designed to lower maintenance and operational cost by adding passive, high-efficiency mechanical systems. For instance, both buildings incorporated renewable energy systems to produce electricity, More specifically, the use of photovoltaic solar systems to harvest energy via the sun. What sets these examples apart from others is that throughout the construction process of these buildings, sustainable practices were implemented. For example, both projects successfully diverted at least 90% of its waste from being deposited in landfills. In addition, both used locally sourced materials and environmentally preferable products as much as they could. A key aspect of the sustainable construction process requires thorough analysis. Some common tools include life cycle cost analysis for retrofitting existing buildings, building information modeling, virtual design and construction, and economic software such as AutoCASE. All of these tools are used prior to the construction in order to properly manage a construction project and design long-lasting structures. Another aspect is time efficiency during the construction process. Remember, time is money. Some new trends associated to this is the use of robotics and automation for assembling and using prefabrication, off-site, and modular construction, which proactively prepares building materials to minimize extra assembly in real time. Although sustainable construction is being successfully applied today, there are still many ways the industry can improve. The construction industry remains economically volatile and faces many hurdles to overcome in order to stabilize the industry for the future. Construction consumes about half of all non-renewable resources, making it one of the least sustainable industries in the world. As a result, it's necessary to promote renewable energy research to make it more accessible financially and physically. In addition, there is a need for innovation to lower cost of high-efficiency construction technologies and equipment. Lastly, it is critical to continue developing systems to quantify environmental cost savings and convey justification of green technologies to owners. These objectives can be attainable in the future, and sustainable construction has the potential to reshape the industry by promoting economic prosperity within communities, improving the standard of living as a whole, investing in renewable energy technologies, and ultimately stabilizing the industry's current volatile condition. Thank you.